Okay, we might make a start. So again, thanks for everyone who's joined us for the second of our webinar series, and a big thanks to Professor Marcello La Rosa from Apromore, who is as the CEO and founder of Apromore, who will be leading this presentation today, alongside Ian Edwards, who's a senior business analyst with Leonardo. So just a couple of housekeeping things before we kick off and I hand over to them. Obviously, we've got the ability for you guys to ask a question as you're going along. So please use the Q&A function here to answer a question or to post a question, and that will be answered at the end of the webinar. For those of anyone who's watching on YouTube, we're not moderating any comments there. So if you've got any questions, have to attend the Zoom webinar, sorry. So next time, come along to the Zoom webinar instead. Other than that, I'll hand it over to Marcello, sorry, if you can just advance the next slide for me, please. I'll just do a bit of a rundown. So these are the webinars we've got coming up. Next week, we've got a webinar on scaling up your RPA journey, followed by a webinar on serverless architecture. And then there'll be a follow-up to this webinar on chapter 2 on process mining, but I'm sure Marcello and Ian will talk more about that. Otherwise, I'll hand over to Marcello to kick us off. Thanks again, Marcello, and thanks everyone for coming.
Thank you very much, Daniel. I think I'm not muted anymore. It's a pleasure to be here. Thank you very much for the opportunity. I would like to start by setting the flooring about process mining. Let me start by giving you a bit of context. Process mining basically started from the observation that often reality differs from the way we represent it. We can see that in popular commercials like the one on the slide, but it also applies to the way we represent or better model our business operations in the form of so-called process models. On the one hand, you can see on the slide a simple example of a process, how we might have modeled it by means of a model, saying the BPMN notation. And on the right-hand side, you may see what it actually looks like, the actual process. And this process may actually hide in reality a lot of complexity. For example, there might be activities that have not been represented in our model. There might be rework, repetition, bottlenecks, pinpoint effects. Often all these details are not really represented in our process model. So when it comes to capturing our business operations, there are at least a couple of reasons why this is the case. First of all, these days, exceptions are the rule. We have a special customer, a claim application with a specially complex type of damage, or like in the case of higher education, we sometimes get students that move from different institutions. And as we know, each university has their own way of assessing subjects' results. So every case needs to be looked at with specific regard. So these are exceptions, and the question is whether we end up representing these exceptions in our process models or not. And the second reason, as we are facing these days with the COVID crisis, is that context keeps changing all the time. This might be internal policy changes, or, like in the case of a global crisis, it might be the entire socio-economical environment that actually shifts. This may lead, for example, to a need for deploying new operating models, right, Ian?
Yeah, and I think with operating models, the thing I think businesses have started to realize very, very closely in the last few months is that operating models can change. Obviously, one consciously, a disruption such as we're seeing now forces businesses to consciously change the way they operate. The second way is the unconscious changes, and this comes from processes changing subtly over time or through a disruption where business might not recognize that their operating model is actually shifting in response to a change in the environment. And so what process mining can start to help businesses to do is provide that information and that evidence so that those decisions, whether they be conscious or understanding the unconscious decisions that are being made, the data coming out of process mining can help those decisions around whether or not the operating model should change, or if it is going to change, what it should change to become much, much clearer.
In fact, the traditional way we try to address this problem is by applying a well-principled BPM approach. So, business process management as a discipline prescribes to diligently model these processes, then analyze them, redesign them by identifying possible changes to address the problems, and so on. The problem with a traditional BPM approach, however, is that this required a substantial effort, and especially when it comes to the first phase, the discovery phase. Often this is carried out by means of interviews or by running workshops with process stakeholders, like, for example, with the claims handlers that are involved in the management of claims on a daily basis. The problem is that this phase of discovery is quite time-consuming, and sometimes PM projects actually get stuck in that discovery phase, trying to perfection, to create better, closer to reality type of models. But as we know, this may be quite time-consuming and error-prone. So the idea of process mining is to preach a paradigm shift from confidence-based business process management, whereby the confidence in these models comes from the understanding of the processes themselves, from the people who we interview and involved in workshops, which might have biased views, right? To an evidence-based approach, where the evidence, as Ian was mentioning, comes from the data itself. So the starting point of process mining is to have a look at the data, either historical or live event streams, that are recorded by the systems that support our processes. Think, for example, of a claim management system in an insurance company or a student admission system in a university. These days, these systems record a vast amount of event data that can be used as input for process mining algorithms. So the idea is to extract what we call actionable process knowledge. So it's a deep understanding of how the underlying processes look like, how they perform. And it is actionable because it empowers ourselves with remedial actions, so with treatments that we may then implement in order to rectify the issues that we have identified. Should there be, for example, a bottleneck, a lack of efficiency, or a problem related to compliance. This process knowledge can take multiple forms. And first and foremost, what we are after with process mining is to reverse engineer a process model out of this event data. And the nice thing about this process model is that it is quite different from the process model that we would otherwise draw by hand, for example, as a result of conducting interviews or running workshops with process stakeholders. It is different because it will capture not only the sunny day scenario, which is what we often tend to focus on when it comes to creating these models manually, but it will also capture all the exceptions, all the infrequent behavior that is actually there and may be the source of problems. So here you see a very simple example of a process model that has been automatically reverse engineered from an event log related to a process for repairing some damage, for example, in some product, right? So you see that each box represents an activity, and each arc represents a transition from one activity onto the next. Even without looking into the details, at a high level, we can see that this process has quite some key ingredients that can help us gain a deeper understanding of how the actual process looks like. You see that this process has been annotated with frequency overlay. This is statistics about the number of cases of this process, so the number of repair requests in this case, have been performed from the log that we took as input. So these are basically these numbers here on the arcs and on the activities. And you can see also that this process as information, so this frequency information has also been encoded in the colors of the activities and the arcs. Thicker arcs represent most frequent handovers of works between activities, whereas darker color boxes represent activities that are taken more frequently. So you see that if I just take a quick look at the path that is made up of the darker color boxes and the thicker arcs, that would basically be the sunny day scenario. And then you see all these little rework, repetition, thin lines, activities that are in a light blue color. Basically, this is everything else that might affect the performance of our process. And a key advantage of process mining is that by the same token, we can automatically transform this low-level model that we call process map to a higher level model, like a BKMN model, that would constitute our starting point for our as-is process mapping. Ian?
And I think here, one of the key benefits that you see out of this part of the capability is the savings that can come typically with your business analysts who would traditionally go out and do their bit of discovery work. They would spend a lot of time modeling, a lot of time validating a process. With process mining, the data will very, very quickly produce your process map, saving all of that time for your BAs, and your BAs can then transition into far more value-added analysis and moving through into diagnosing either issues or looking for opportunities. The second extension to this capability then is taking this data and starting to use the capability to provide a simulation, a what-if analysis. So one of the key business use cases obviously is then to start looking at, well, we want a brand new process, or we want to adapt this process to a brand new scenario. So if we were to take this data and start to overlay new arrival rates for the amount of inputs into the process, change the resource volumes or the resourcing distribution, or even change the business rules, or change the flows of what happens when those business rules get executed. All of a sudden, you can start to see a simulation of what a new process would look like before you deploy and before you spend a lot of time and money implementing a process that may not be fit for purpose.
And with process mining, depending on the information that is contained in your log, you can actually switch the perspective from an activity-centric perspective, where the boxes represent the activities in your process, to, for example, a resource-centric perspective, where the boxes in your model represent the resources or the roles. So all of a sudden, you can dynamically switch from a process model to a social network that focuses on the interactions in terms of handovers of work between the various resources. You can see what would be the most clogged resources, the busiest ones, as opposed to the ones who've been allocated less work. So you can change different perspectives, so analyze your actual process from different viewpoints, whether these are the activities, the resources, or the business object life cycle, like the life cycle of a claim or of an order.
And in a very practical example, sorry, Marcello, in a very practical example, if you were to take a data log from, let's say, prior to January, and you looked at a key process in the end of last year, and you looked at the social interactions and the handoffs and the flow of tasks between resources, and you were to then take the same process, but a data log from the last 3 weeks, you might start to see that changed working environments, changed working from home, or simply the difference with the way the business operates under a disrupted model starts to show a very, very different way in which those resources interact. You might then start to see tasks that are skipped. You might see business rules that are changed in their application. You might start to see relationships between resources and tasks that are either not in the expected model or start to maybe even enhance the process. And so the ability to take a data log before and a data log either during or after and compare those and start to see the subtle differences as to how the business operates is very strong capability.
Thank you, Ian. Mining a process model is a starting point. Another thing that we can commonly do with process mining, given that we've got the timestamps of the various events in the log, is to use this as a starting point to extract a range of statistics related to the duration, also the temporal dimension of our process. And we can use these statistics, again, as another type of overlay on top of the process model that we've reverse engineered from the log. So you see, I'm showing the same process as before, but now I'm using a scale of red, like a gradation of red colors, to capture the duration of the various tasks. The darker the color, the longer a task has been observed in the log. For example, here I'm using average duration. And the same goes with the arcs. The thicker and darker red color is the arc, the longer is the waiting time between the completion of an activity and the beginning of the subsequent activity. A view like this of the process model, whether we are focusing on the process map or on the higher level BPMN model, offers us insights into what could be issues related to waiting time. So that's a type of waste in lean terminology. So, for example, tasks that constitute a bottleneck because they last an excessively long times, or even issues related to resource capacity problems. For example, a task whose all incoming arcs are take quite a long time, which indicates potentially a resource capacity problem, meaning we don't have enough resources to perform the task, so cases queue up at the doorstep of that task. And there are different ways in which this duration statistics can be presented to the user. For example, they can be shown as an overlay on top of the process models, like in this case, but we could also build a dashboard where we show the statistics at an aggregate level. For example, here you see a distribution of active cases over time. So we see that in certain periods of the year, we've observed peaks, so spikes with a higher arrival rate. Or you could look at the distribution of resources and basically how they take on work, who works the longest amount of time, who works the least amount of time. And the same would go for activities or any other data attribute that is present in the event logs. So we've seen how we can use process mining to reverse engineer a process model, and now we can use that process model as a starting point to overlay different type of information, such as duration statistics. Another common type of analysis that we can carry out with process mining is the so-called conformance checking analysis, which aims at extracting a conformance report. So as we said at the beginning of the presentation, the very starting point of process mining was the observation that the way we model reality is actually often different than reality itself. So we tend to create oversimplified representations of the actual business processes. So now if you have a model process available in your organization, say a normative process, a standard model that defines the way your process is supposed to be performed within that organization, like this is the way we do claims, or this is the way we accept loan applications. And you even attach some KPIs to that process. For example, our repair model, our repair process has an expected completion time of 8 hours. So each repair should be completed within 8 hours. Then what you can do with process mining is to compare that standard or idealized or to-be process model with the actual process and check differences not only at the structural level, for example, finding out that certain activities are executed in reality but do not exist in your prescribed model, or certain orders in which activities are performed. You see in the example on the right that we've got some ping-pong effects between certain activities. But you can also compare this in terms of performance. This is the expectation 8 hours, but in reality we take up to 18 hours. And like for any other category of process mining techniques, there are different visual analytics that you can present to the user to allow them to get better insights into the problems and the origins for such problems. This is, for example, an alternative view of conformance checking, where we take the BPMN model that has been produced by the user. So this is, for example, the prescribed process, and then we overlay the discrepancies with respect to the data log. So we see that in some cases we perform these two extra activities and skip this other activity, archive repair, in reality, and this is not prescribed in our model.
And so from a practical business perspective, there's probably two key use cases for conformance checking. One is fairly obvious in terms of compliance. So where a process requires a certain flow and a certain set of tasks to be performed to be compliant, this part of the capability can very, very quickly show visually where the process is or is not compliant with the required regulation. The second one is more the practicality of business rules. So business rules get applied to processes, every day. But this capability then can start to show the business where those business rules are or potentially are not practical for the business use. So we might have an oversimplification of business rules. We might have too many rules. We might have rules that never get executed. We might have rules that are frequently required to be worked around or find exceptions for them. And so this part of the capability can very, very quickly show in a visual sense where those business rules are they practical, are they compliant, and then allow you to make decisions about how you go forward.
Thank you, Ian. In fact, another common case is that instead of checking a prescribed model against an event log, we actually check a set of rules and verify whether these rules are met or not. And often, for example, rules like 4I principle, so checking that there is a proper segregation of duties between activities, or whether certain SLAs are met, between a task and another task, like there shouldn't be no more than 5 hours. These are very common application cases for conformance checking in process mining. So moving on, another very common category of techniques is those that revolve around the so-called variant analysis or change analysis, which aim at extracting differences, but this time not between a process model that has been created internally in the organization and the data log, but rather between different slices of the same data log. For example, in variant analysis, what we want to do is to use a technique called filtering to segregate cases of the same process that belong to different variants, and then automatically reverse engineer a process model from each variant and use these models as a starting point for comparison, with the aim of identifying differences between variants. For example, here in the slide, you see two variants that have been extracted from the same source log. One that relates to simple repairs and the other that relates to complex repairs. And there can be different logical drivers for identifying variants. Here I'm looking at the type of request, but it could be the type of product, the type of customer, the geographic area, or even performance measures, such as cases that meet the SLA, for example, to be completed within 8 hours, and cases that violate the time SLA, so those that take more than 8 hours to complete. And again, tool support can be offered to automatically identify these discrepancies between variants and use them as a starting point to gain insights into the root causes for these discrepancies. And the variance analysis can be done on top of process models, like in the example shown on the slide here, but it could also be done at the aggregate statistical level by using a comparative performance dashboards. For example, here we see the distribution of resources over different types of cases. So for example, we see basically how the different resources work in this process between simple and complex type of repairs, right? So this is another type of visualization. Or another feature of process mining tools is the ability to replay history. And this is quite interesting. So this is different than simulation. We can take a process model that has been reverse engineered. Like, for example, this is the process model that has been reverse engineered for both simple and complex types of repairs. And then what we can do is actually to start animating the data set on top of this process. So it's like the VAR in soccer or the replay that we see at the Australian Open. So basically you see history being replayed on top of this process model, whereby each token, based on its color, represents a specific case that belongs to the simple variant, in red in this case, or complex variant in blue. And this type of comparative visualization, where we basically animate history over time, and we do that per variant, allows us to gain insights into differences in the dynamics of the execution of these variants. So basically, we might find out that there is a bottleneck in a particular variant that does not exist in the other variant. Or we might see that there is a path that, while it belongs to both variants, is very infrequent for one type of product, and on the other end is very frequent for the other type of product.
This is a very useful capability for discussing process and process change with business areas, because whilst the animation can show very clearly how the flow is in reality, the speed of the tokens is in proportion with the process, and obviously start to see the differences in flow can give a business team a very clear idea about how this process is being executed, how resources are being utilized, and a very visual way of especially showing decision makers the effect of decisions on processes.
Thank you, Ian. Still related to this idea of identifying differences is another type of analysis, which is called change analysis. And this is very topical these days. So it's the ability to compare variants, but not based on logical drivers or based on performance measures, but rather on the time scale. For example, comparing what the process looked like before, for example, in our case, before the crisis started, versus the process, how it looks like during the crisis, as opposed to after the crisis. So basically, we can check the evolution of the process over time by setting specific points in the timeline, before, during, and after the crisis.
I think here, for a lot of businesses, they have a very clear view about their processes, obviously in the before state as to how they're working, but the ability to see that process and compare it to, a very live situation, and then have a look after, the disruption is over, and what does normality, what sort of normality we return to. We might find that during disruption, there are elements of that process that we would much rather retain. There might be business rules that, or policies that might be, much more lenient during disruption, that either were in place beforehand or were causing bottlenecks. So I think the ability to see the same data sets but from different timescales just gives a very clear visual on what do we want to keep, what do we want to throw in the bin, and what's working, what's not, and where do we want this process to be ideally, because you have that evidence of the before, during, and after.
Thank you. So, and last but not least, we can tap into live streams of data to issue predictions about the open cases as they unfold. For example, it is possible to predict whether a particular case of our process, say for example an open claim or a loan application that we received or an order that we are currently fulfilling, whether that will become deviant or not. Deviant with respect to some rules, some service level agreement. For example, we may predict with a certain level of confidence whether this particular claim is going to violate the SLA at 5 days, meaning it's likely going to take more than 5 days to be handled. We may also be able to predict the outcome, again on a case-by-case basis. For example, we might be able to predict whether the loan applicant is going to reject or approve or accept the loan offer. Or we might be able to predict what is going to be the amount of repayment for a given claim. So there are different types of characteristics of open cases that we can predict. But the important bit here about predictive monitoring is that with this, basically we shift the focus in process mining from process analysts and process owners as the target audience of automated discovery, conformance checking, variance analysis, and so on, versus operations managers and the actual process participants, like a claim handler, as the target audience of predictive monitoring. So the idea of predictive monitoring is basically to support these resources to take interventions before the problems arise. So to try and anticipate the eventuation of a particular problem, like an SLA violation. And a remedial action may be, for example, shifting some resources from one claim onto the other to make sure that this latter claim is completed on time. And of course, the way this information, these predictions can be visualized is by building a so-called predictive process monitoring dashboard, where basically, together with live data, we see a series of predictions, e.g. predicting the remaining time, the outcome, the next activity, or the violations of some SLA rules.
And as you mentioned, process managers, those that are executing the process and are managing that flow. That these types of dashboards, this is one such configuration, but depending on the preference for what data needs to be viewed, those top lines can be configured to show exactly the types of analytics and data that helps that decision making. But as you say, whether it's for simple, are we going to meet our SLAs, to what is the probability of a supplier failing to supply, what's the probability of a customer not being pay, the process, are we going to these orders today? How long is this process likely to take? And when are we going to be ready for the next stage of the process?
Thank you, Ian. So to wrap up, we've seen a range of techniques for process mining that we have categorized under automated discovery, performance mining, conformance checking, variance analysis, and predictive monitoring. And with Ian, we've discussed, we've provided some examples of common use cases where each of these techniques could be applied. So now let's take a step back and do a quick recap, talking about the values that process mining enables us to achieve. So first and foremost, as you've seen, the starting point is achieving transparency. So getting a deep understanding of how the actual process really looks like. The way we achieve that is by reverse engineering the process model through techniques that go under the realm of automated process discovery. Now, transparency itself works as a trigger to enable us to achieve other values. For example, gaining efficiency in terms of reducing costs, like operational cost, or reducing the cycle time of the process. So here we can use techniques like enhancing the process model that we've reverse engineered from our dataset with performance overlay, right? With statistics related to the frequency, like the number of cases each activity has been observed in, or the duration, like the average duration for each activity or for each handover of work between activities. We can also use performance dashboards where we can plot statistics at different aggregate levels, like, for example, the distribution of cases over time. And we can also use this technique called log animation to replay historical data on top of the model that we reverse engineer from the log. And all these types of analytics can help us gain insights into where potential efficiency gains are. Another common value enabler is quality. So using process mining to improve the quality of the customer experience, so the quality of the service, or even the quality of the production process itself when it comes to a manufacturing domain. For example, here we can use variance analysis. So we filter out cases that belong to a specific variant from cases that belong to another variant, per product, per geographic area, or along some performance dimensions. And then we do a comparative analysis between these different variants, either on a process model level or by means of dashboards. You remember this comparative dashboard example, or by animating multiple logs, so related to the different variants, on top of the same process model to identify differences in the dynamics of the process. So, for example, the idea here would be to look at cases that negatively deviate from some goals, e.g. those that take too long to complete, and compare them with those that actually are completed within time. And from their differences, try to understand why this problem occurs, right? So why certain claims take longer than 5 days to be handled. So we've also seen how process mining can be used to increase compliance. And more generally, we talk about governance risk and compliance, so the GRC area. So for example, here we can use conformance checking, where we compare a normative model against the model that we extract from the log. Or we could do rule-based filtering, as we mentioned before. For example, we could check whether in reality we meet or violate a specific business rule, such as segregation of duties. And last but not least, especially very relevant these days, is agility. Using process mining to identify how quickly we can react to planned or unforeseen changes. So, for example, here we can use simulation on top of so we can simulate the model that we have, the as-is model that we have reverse engineered from the log to evaluate different scenarios, to react to different types of changes. We can do change analysis, even more specifically, where we basically do a temporal profiling of our process, how it has been evolving over time, before, during, and after the crisis. And then, if we want immediate reactions at runtime to anticipate the occurrence of certain problems, then we can look into predictive and prescriptive monitoring. So this was a very, Ian, do you have any remark on this slide?
No, Phil, I think you've covered that. I think you've covered that very well. There's some questions, I think, in the Q&A that'll probably touch on this as well.
So basically today we just provided a quick introduction to process mining, what it is in terms of types of techniques that it provides, and why do we need it. So what is it that we can achieve with process mining? You know, efficiency, agility, quality, and so on. We have another seminar planned for the 10th of June, where we're actually gonna go more in depth into each of these techniques and show you the how. So practically, against a concrete tool, our own Apromore process mining tool, we are going to show you how to perform some of these analysis techniques, starting from a data set. All right, so I think we can move to some questions. and
Yeah.
answers
So we've got a
time.
few questions that are in the Q&A. So thanks very much for those who put those in. If you've got a question, I know we're up against time, but we'll get through the questions as we have them. So I'll ask the first one from Gurav. I hope I've pronounced that correctly. Is there any structured approach or document, or we study the process historical stats?
Yes, so there is a structured approach to follow to carry out each of these analysis types. So as I was showing in this slide before, depending on the value that we want to achieve, whether there is quality or efficiency, there is a specific set of techniques that we can follow. For example, for efficiency, we can use log animation, performance dashboards, and enhanced process models. And in order to get analytics out of each of these techniques, there are some steps that we can follow. But one important characteristic of process mining is interactive nature, which is the fact that there is a procedure that we can follow to get to the results, but the type of analysis that we perform is often very explorative in nature. I mean, as we carry out the approach, we may find out we may get some findings that we weren't aware of, and which may lead us to reconsider the approach altogether and the type of techniques that we are using.
I think one other answer to that probably leads into one of the other questions on the Q&A around the process of actually getting this up and running and getting the data. The data itself, to start this off, comes directly out of your source systems. You would typically extract a CSV file extract, and that file extract is uploaded into the software on which the algorithms work. That event log or that CSV file extract only needs three key things. It needs obviously the event detail. So we obviously an event for each of the steps of the process or the stages or the tasks that are being performed. Timestamps on those events, whether they be the end timestamp, or even better, the start and the end timestamps of that activity. And then obviously a unique case identifier. So that case identifier might be a file ID, it might be a customer ID, it might be an item number, or it could be a concatenation of all of those. It might be the origin, the date, the specification, the item code get concatenated together to create a unique ID. And that ID then shows you in the history log each of the stages of that process as it flows through. So typically the stages of this would be to obviously understand whether this is are you looking at the project as a opportunity, or are you looking at it as an issue identification or issue rectification? And I think depending on what the issue is or what the driver is, you may start with a slightly different point, but all roads lead to trying to find the data set that relates to that process. Critically, getting the data out of the systems, it's smarter to get more data out of the system than less, and then remove the irrelevant data before you load it up, rather than load up event logs and find that there are critical pieces of that data missing. And once that data is loaded and cleaned, there's a whole piece around cleansing the data and making it ready for use, and especially cleaning the data so that business friendly terminology replaces maybe system or code based speak. And then it's a case of obviously the auto discovery and starting that analysis. But we can probably go offline into a bit more around the longer the process around that, if that would help.
Yes, and just a quick remark on that, Ian, and that is also related to another question that was asked later about what would be by Kevin Tan, what would be the number one challenge in implementing process mining to business? Clearly is the availability of data, and the challenge related to getting this data ready for process mining. However, so Ian mentioned about cleaning the data and pre-processing that. However, what we tend to do is that we do this the first time manually to find out exactly what cleaning operations, what data preparation operations need to be done in the context of your ETL, extraction, transformation, and loading pipeline of data. But then this procedure can be automated. So you can build connectors from, or many connectors already exist, from your process mining tool to your source system, so that you can automatically ingest data from one or more source systems, do the automatic transformation and pre-processing, and then import them into your process mining tool for analysis. So this operation can be automated. Another challenge is clearly getting culturally ready for the type of insights that we can unearth with process mining. And here you have two types of attitudes. You have the attitude of those that are eager to find out as many problems as there are, and to use this as a starting point to effectively improve your processes. And there is also, unfortunately, the attitude, at least in my experience, I've experienced that a few times, of those that prefer to cover up. And this is clearly a cultural barrier to the implementation or to the successful implementation of process mining within a corporate environment, because you are going to unearth problems whose origin you might actually be responsible for, right, as a process owner.
I think in our experience, though, it doesn't take very long for especially business and decision makers, once presented with evidence-based process information that shows exactly what's going on, it is very hard to argue against data-driven evidence, especially when you can start to see the effect. And most decision makers have a set of a very clear understanding of what the effect of their processes is on their business outcomes. So it does over time start to become easier to get across that cultural barrier, because it's very hard to argue. One of the questions on here: can we perform process mining without having a process model? Often goes to that point as well. Often it's much better to start without a process model in mind. Once again, having a traditional process model, people are very invested in their processes. Often times they're very precious of the work that they've put into those process models, or it might be their own area of business and might not enjoy the scrutiny. Often when you start without a process model, there is no predisposed expectation as to what the process should look like. Therefore, you can jump straight into looking at the evidence. So no, you don't have to start with the process model, and often it is better to start with one.
Okay, so the next question here is from Stuart. Are there some guidelines or rules of thumb as to how you decide what level is suitable for process mining, e.g. when to scope as an end-to-end value chain versus within a department or function only?
Stuart, the way I'd answer that is depending on the outcome that you're looking for. So if you are looking for an outcome that touches a process that is at a very much a business unit level or a functional level, then I would start obviously at that level, but depending on where the impact is, and if the impact is at a business level, I would start as broad as possible and start to then narrow down. Obviously processes, once you start looking at a very narrow focus, you can obviously start to change your train of thought into a very narrow focus. So if the impact is at an organization level, I would definitely be trying to start at an organizational level and then move down to where the core of that problem is, rather than the other way, which you can start to miss the impacts. You can look at a process at a departmental level or at a functional level and find no real issues at that level, where the issue is appearing at a much greater level. So the higher level the data set is where I would start in that sense.
Another question, do you have an order of magnitude in savings whereby process mining accelerates the traditional subjective process modeling approach?
So there are different factors that can affect the savings. So there have been cases reported in the literature where this has gone up to various millions of dollars. But it depends on context by context. So it depends on the specific organization, on the problems that you unearth, and what areas they affect, and clearly also on the level of maturity and appetite of your BPM initiative. So, for example, there have been companies that have reported multi-million-dollar savings in terms of as-is modeling. But the greatest savings are really in the ability to identify, to get a comprehensive view of where you can cut costs, where you can achieve efficiency and quality gains, where you can improve compliance. So take an insurance company. They are subjected to fining, so they can be fined if they violate certain SLA agreements with the claimant, right? So now multiply that by the volume of claims that get handled in a given type of claims, and multiply by the number of violations that occur, and so by the potential of being fined, and that can give you a bold figure of the savings that the company could achieve. For example, we worked in the past with Suncorp, as you know, it's a large insurance group here in Australia, and we helped them identify causes for unacceptable delays in the processing of commercial claims. And we managed to help them reduce the average duration of these commercial claims from 1 to 2 months down to up to 5 days. They reported a 30% saving in resource utilizations, resources that then they could allocate from this type of claims to other type of claims.
Great, thanks for that. Another question, what if we don't maintain an event log?
So what is important is not necessarily to maintain an event log that is nicely formatted with the exact type of attributes in the exact order as we need them for process mining. What is important is to have the source for such data. So to have the somewhere in one or more systems, the tables that contain this information, and that this information can be extracted. Clearly, if that is not the case, then process mining is not applicable, and we need to resort to traditional process discovery methods like interviews and workshops. In my experience, this has hardly happened, that you are not able to find any data, completely zero data, that is useful for process mining, because of the very nature of today's business processes. They are basically supported by enterprise systems, right? In the great majority of cases, but still that could happen. And in that case, of course, the only thing that you can do is to basically instrument the systems in order to be able to log this information, so that in the future you would be able to run a process mining exercise, right?
And obviously the potential of process mining is in itself a good support for a business case for better or more detailed data and data management. One of the clients that we've worked with used their experience with process mining to expand their data capability, their data resources, and start to look at automated data extraction and clean up their data to enable that much better.
Another question here, which was from Mark, what if there isn't a case ID?
Yeah, well, once again, we can use the data that is there and concatenate. One of our other clients had certain attributes that they wanted to, but I think there was 4 data attributes that needed to be concatenated together to create a unique identifier. But as long as those attributes are in the data, we can bring together, let's say, a date. There was a processing geography piece of data in there. There was timestamps, and so the concatenation of 3 or 4 pieces of data together, we just simply created one more data column for every line in the data set, which was the concatenation of those 3 or 4 pieces, which then created its own unique ID. And that way you have something that's transferable across the whole data set or multiple data sets.
Another question is they're coming thick and fast. From Praveen, is my assessment correct? Process mining can also point to areas in business process execution which are not yet digitized and can prompt process owners to digitize such areas or events.
That is correct, Praveen. And there are 2 use cases for that. You could use process mining to identify entire processes that might be amenable for automation by means of a BPM system, whereby the end-to-end process is automated. This would be those very frequent, highly repetitive, yet domain-specific processes which are not supported by out of the box by systems like ERP or CRM systems. So, for example, excluding sales, accounting, payroll processes, you'll be looking at domain-specific processes like student admission in a university or claims handling in an insurance company. So process mining based on these statistics that you can extract and use to overlay on top of the discovered models, such as frequency, duration, can help you identify those processes that would be basically most amenable for automation at the entire end-to-end level. Another use case is to identify opportunities for automation at the task level, e.g. by means of robotic process automation tools. This would be those highly repetitive tasks, often short-handed, where they are highly repetitive because maybe they are manually carried out and they are error-prone. Of course, you need domain input to that analysis because the tool could identify a set of candidate tasks for automation, but then you need to exclude those where you know for sure you need human input because they would not be classified as clerical tasks that you can replace with an RPA bot. But the answer in short is yes, process mining has been already used a number of times to help to assist organizations identify opportunities for process automation, both at the task and at the process level.
Thanks, Marcello. 2 more questions and then we'll wrap up. So from Olga, can you share a memorable experience in the industry, maybe insurance industry, where predictive process mining was definitely a hit?
Yes, we had an application, Olga, with a company called Unipol. It's a large insurance group in Italy. They asked us to create a predictive process monitoring dashboard for their motor vehicle claims. They had 2 SLAs at 30 and 60 days, and they wanted the predictions to assist them at runtime as claims get handled into basically recategorizing, reprioritizing claims is on the basis of their likelihood to violate the 30 and 60 days SLA. Another type of prediction that they asked us to build was the amount of repayment. That again could be used to reclassify, to reorder the claims from the highest to the lowest expected repayment. And then another one was the next activity, the most likely activity that is going to be executed next to help them with scheduling. So this dashboard was looked at by the claims manager as well as by the various claims handlers. And they had 2 goals. One was to minimize the overall number of SLA violations, because like in insurance, you are subject to being fined for SLA violations. And the other would be to spread the workload across different claims handlers as evenly as possible. So basically, they use these predictions as a starting point to identify remedial actions on the basis of the predictions that were put forth to them. E.g., if this particular claim is highly likely to violate the SLA, a remedial action could be, in order to avoid this problem, is to shift the claims handlers from one claim that is pretty safe to this particular claim that is close to violating the SLA.
One of the other examples that I've got from one of our other clients, the manufacturing company, they're looking into predictive dashboards at the moment. And one of the things that they were excited about was their ability to see what is the next order, what are the next orders that are likely to be finished, so that their logistics team can start to pre-plan shipping. So previously, the ability to be able to ship orders was reliant on getting historical data about what was finished. These predictive dashboards hopefully are going to start to show them the ability that these are the next 5 orders that are going to be finished today or tomorrow, and here is the time at which they're going to be rolling off the line, and therefore have trucks ready at that time for the delivery. The second one is then supplier predictions, and we're looking into whether or not manufacturers can have predictions on the quality of the product coming from suppliers. So looking at geography, looking at the types of product that are coming in, looking at the prices that they're paying, and being able to get a very clear view at a supplier level of what is predicted to be the quality of the produce that they're buying, and therefore be able to either avoid or target certain suppliers with better results.
Last question here from Kevin. What's the uniqueness of Apromore that it's a better tool than other process mining tools? We've got a whole webinar that's going to be about that, Kevin, which is a great lead into the one that's going to be in a couple of weeks. But Marcello.
So very quickly, you saw that the screenshots that we use in the presentation were actually taken from Apromore. This is a tool that we've been developing for over 10 years. It starts from our research efforts at the University of Melbourne and other leading universities in the world. So 3 unique points. First of all is leading edge. Every single algorithm derives from our research efforts. So it's basically state of the art. I showed you some BPMN models that were automatically extracted from logs. These are based on a very sophisticated algorithm that goes by the name of split miner, and we have done an extensive benchmark to show that this is the fastest and the most accurate BPMN mining algorithm. The second is the fact that it's open source. So it's transparent, it has an open architecture, it is highly extensible. And the third one is that it has a capacity-based pricing, meaning that you can start very small and grow incrementally in your uptake of process mining as your initiative matures within your organization. That means that there is no limit in the number of users, accounts, nor on the size or number of processes that you can actually input. There is a last question from Olga that I mistakenly marked as answered. So I think this is a follow-up from the question about predictive monitoring. Olga is asking, but this kind of changes require flexible process models. Not necessarily. They require flexible procedures, meaning they require the ability to modify your process on the fly. It doesn't need to be necessary. It doesn't need, so all these possible actions that you can perform at runtime do not necessarily need to be hard-coded in your process model. The specification may be loose so long as these actions comply with certain policies. For example, the ability to relocate resources from one case to the other, or the ability to drop a check in order to meet some temporal deadlines, right? So you need to have a policy basically that allows you to be more tolerant to risk in that particular case and drop the check. The problem, if we wanted to encode all these rules in the process model, is that some of these might actually not manifest themselves in the terms of control flow. So it's like a change, like shifting resources from one case to another is not something that you can visually see on top of a process model. The other is that we may unnecessarily clutter the process model by overloading it with all these rules. So it could be like a basis process model with the main flow and the exceptions, plus a bunch of rules that are associated with the way we execute that business process.
All right, we've gone well over an hour. There's been lots of questions there. That's been fantastic. Thanks for those who are still here. So Marcello, if you just want to forward to the slide 30, I think it is. Yeah, so we've got a webinar next week, same time, on scaling up your RPA journey and considerations for business. A very practically focused webinar around RPA, if that's something you're interested in. Otherwise, thank you, Marcello, and thank you, Ian, for a wonderful webinar. And thanks everyone else. We'll see you next week if you're going to be here. Thanks again.
Thank you very much.
Thanks.
Thank you all.